We've seen two examples of how to visualize hydrogen atoms coming together to make a hydrogen molecule. And you might get the impression that, wow, this works for anything. I can just take two atoms, smack them together, they'll always make a bond, and everything forms bonds. Well, that's not true. So let's look at a reaction that does not work. So here's a helium atom. Helium has two electrons in its valence shell. And if we bring this together with another helium atom, we could potentially envision making an H2 molecule. Well, this doesn't happen. Helium atoms are stable and they do not form helium molecules. Let's see if we can explain why this is through a bonding picture. Specifically, I'm going to look at this from an energetic standpoint. We're explaining, does this want to happen? Is it energetically favorable? Therefore, we're going to stick with our energy axis. Again, that's high energy and that is low energy. So we're going to bring together two helium atoms, and these heliums have 1s atomic orbitals, and it has two electrons over here, and we'll do the same right here to the right. Two electrons. This again is a helium atom. This is a 1s atomic orbital. And as these two atoms approach each other, here's our before and here's our after. Before, and after. These atomic orbitals are going to mix together and form two new molecular orbitals. How do I know we're going to form two new molecular orbitals? Because we're combining two atomic orbitals, and the number of orbitals will always be conserved. So here's a new molecular orbital. Here's another new molecular orbital. They have different energies. This is going to be our sigma bond. This is our sigma star, our antibonding orbital. And now let's drop in our electrons and see what happens. So we, instead of having two electrons as we did in hydrogen, the hydrogen molecule, now we have 4 total electrons. So these electrons will fill up the lower energy orbital first. They'll fill up down here. 2 electrons go down in energy. 2 electrons have to go up in energy. And this distance from the middle is approximately the same. In fact, the upper distance is a little bit higher, but they're roughly the same. So any energetic benefit of putting these electrons in the lower energy sigma bond is offset by raising the energy of these other 2 electrons. There's no energetic benefit to forming this H2 molecule. Therefore, these helium atoms would rather stay as helium atoms. They don't form H2 as a molecule. So we can energetically use these orbital pictures to explain why some reactions are favorable, why some reactions may not be favorable, through really fairly simple descriptions of covalent bonding. So not everything forms covalent bonds, at least stable covalent bonds. And we can understand this through these simple energetic pictures.